You're in for a huge, exciting day with some of the most knowledgeable people in ham radio. One of them is not me. I'm just a little joker that comes along, but I do have some interesting things that you will want to pay attention to. We're very, very fortunate to have a professional video guy here. And the thing is that all of these will be posted on Nick's website. How many of you went and looked at the videos from the last few? Has anybody done that? There's some really great videos there, and that's what's going to happen with all this.
Good morning, everyone. Thank you for coming out. I'm Nick Tusa, K5EF. Obviously, from my voice, you can tell I'm not from here. Grew up in New Orleans, Louisiana. And as a young kid, I got to meet Mr. Shum when I was in high school. We had a club radio station that had a Central Electronics Model 10A exciter and a 75A1 and a sideband slicer, and I didn't know what any of this stuff was because I was a brand new ham, and all the single sideband radios I ever saw or tried to experiment with had filters in them, like mechanical or crystal filters. And I opened the hood of this thing, and where's the filter? You know, how does it make single sideband? And that got my interest. And at that point in time, I started conversing with Wes via mail. I'd type little letters to him, and soon enough, I get a phone call back, and that began a long-time association that lasted many, many years. But I'm very pleased that you're here today. We're lucky we have Wes's daughter, Diane, and her husband, John Vogt, that are here with us today. They've been gracious enough to host a symposium over at their Storybrooke Farm bed and breakfast in Jonesboro, Tennessee. And this last year, we actually had the first one off-site down in Slidell, Louisiana, and now we're here. And very pleased to be here. We've always wanted to have a venue that was a lot more centrally located so that people that had an interest in home brewing or vintage radio, or restoring radios, vintage equipment, would have a way of meeting up with other people that enjoy doing the same thing. So we're pleased to have you all here today. We've passed out a kind of a syllabus of what's going on today. Unfortunately, we have one change, Dave Beckler, which Dave was going to talk about the Collins S2 line. Unfortunately, because of a medical issue, he couldn't make it today. So we're going to have a break at lunch. May have also a discussion about a homebrew rig that Bob Nichols has been kind enough to bring down here. It's quite unusual. But again, at 10 o'clock today, the symposium will be able to host you folks that have pre-registered at will call. You'll be able to pick your tickets up and also buy tickets tomorrow for tomorrow's events as well. Our first presentation this morning is by Bob Nichols. And, you know, SDR radio certainly was not something that Wes Shum would have known anything about back in 1951, 52. But a lot of the principles that he employed in phasing are in SDR today. Bob, are you ready?
Yeah, we're good to go. Thanks, Nick.
Great.
Let me ask,
You're not going any further.
I'm gonna, we don't have any cordless mics, do we, Bob? Yep. All right, we'll just do a little,
We've got a stretcher.
little song and dance swing then. Is Dean here? Dean? I don't know the fellow, but we'll maybe see him later. I just echo what Nick said about thanking you for coming. I've been a ham for a bit over 50 years, and all that time I've been making radios of one kind or another. I mean, it's just something that gets into your blood, and as many of you know, there's the ESD test. And as many of you know, you can't have too many. I mean, once you start playing radio, it's like you're in a quest for the better one and the one that's, oh, here, I see what we're going to do.
All right. You are on the air.
Where there's an XLR extension, we're good to go. Thanks, Bob. What better audio video guy could you ask for, right?
On loan from Joe Walsh.
Thank you, Joe. Life's been good. So to get into my talk, it is going to be about SDR, but it's also going to be mostly about receivers. And why do we care about receivers? Well, what have we been taught since day one? If you can't hear them, you can't work them. And it really doesn't matter whether it was in the 50s or in the 60s, 70s, whatever you got started in radio, chances are you fought with your receiver and you were on this quest to get a better one. So I just thought we'd start by reviewing kind of the history. And, you know, if you go all the way back, by the way, that's the manual version that led to the one with a little tapper on it that automatically knocked the little particles loose. So, you know, in the previous century, crystal detectors came along pretty quickly and were pretty popular because that made it much easier for most, for AM broadcast at least. Spark. And then DeForest invented the tube, the Audion. If you're watching the time up there, you know, it took about 12 years. And of course, there were many failed attempts in between, but it still happened pretty quickly. And of course, the guy we owe more than most to, and that is Major Armstrong, who first gave us regeneration only 2 years after the Audion came out. So he was a pretty busy fella. I mean, he could see the need for additional gain, and he came up with a circuit, and of course the rest is pretty much history. By the way, all that has something in common, which I'll tell you about in just a minute if you haven't guessed. But then Armstrong, you know, of course wasn't satisfied, and he proceeded to develop the superhet. And you probably can't find a better example than the SX-28 as a pre-war, you know, epitome of the superhet art, which it came along in 1940. So it really took a while to kind of get through some of those early generations and get to where the superhet was the king. Yeah, kind of fast forward. What's happened? I think an invention that is tantamount to Armstrong's in terms of its impact was the Taylor detector, which you'd also know as QSD, or the quadrature sampling detector. And why is that so significant? By the way, it just went off patent. So 20 years ago, just went off patent last October, or an October ago, I should say. Well, because that's what Gerald Youngblood wrote about in his article about software-defined radio for the masses, which kind of turned everybody on. And that happened in 2002. So in the meantime, there were a lot of guys fooling around and building little simple radios using the QSD principle. But that's really what gave birth to Flex Radio. And it also gave birth to the soft rocks. How many have built a soft rock? That's a pretty good sample. Why? Because they were simple, they were cheap. And how many of you were amazed when you first plugged that thing in and got sound out of your computer that sounded like a radio? I know I was. And so the soft rock kits came out a couple years later. You can still buy them. And of course, quite a few more. But that was all built on Taylor's work, which, you know, was patented by Motorola and put in the public domain. So we really owe a lot. But another thing happened, and that happened because we're now in the age where everybody's running around with a two-way radio in their pocket. They just call it a smartphone. And because wireless technology was becoming so prevalent, people wanted to do different things with it. And one of the things was to watch television. So where you had digital television in Europe, you needed a front end, a receiver. And that's what happened when the R820T was developed. It's basically a tuner on a chip. I said radio on a chip, but it kind of led the way to radio on a chip. The real radio on a chip, that's your Bofeng handheld, right? That's an SDR in a chip. That allowed me to do something which I was excited about then and now, and that's to write this article, which I borrowed from our phasing SSB forefathers and called Cheap and Easy SDR. Because you could take one of those R820T dongles and RTL SDR software that was free on the internet and make a working radio. What I added was the HF up converter, which was very simple, but it allowed us to move HF up into that VHF range that this tuner handled. And I'll talk a little bit more about that. And then what came along that I think is equally significant is the ICOM 7300. Everybody own an ICOM 7300 yet? It's probably more than build a software. I figure we'll be done when everybody owns a 7300, and then we can all say we're fully equipped. But why is it significant? It's because it's the first direct digital down conversion and direct digital up conversion SDR. And I'll maybe not talk much about that today, but you know that's going to be the future. Back to the 820T for just a minute. Why was that important? Well, the important thing about it was a silicon-based tuner. It took all the stuff that you needed to make a radio, a receiver, kind of a superhet. I mean, if you look in there, there's a local oscillator, and there's mixers, at least one in this. There's only one in this one, that's right. So this is really a superhet radio on a chip without the IF. And the next chip to it, the 2832, down converted that to a USB stream, and being able to do the DSP was easy work for a PC. And we're now at the point where it's easy work for a small Linux platform, which I'll demonstrate. So really, I think it was kind of a turning point when we started making receivers out of silicon. 4 years, hasn't been very long, ST, which is kind of one of the innovators, has developed a new chip called the STA709, and that's what is inside this little SDR. The STA709 is pretty remarkable because, whereas, as Nick said, Wes and Joe Batchelor dealt with phasing in quadrature phasing, now we have polyphase phasing. And the reason I underlined it is because they could have just as well as came right off their data sheet, and you're very constrained with ST. It's about all you're going to get from them unless you sign non-disclosures and submit financials, and they don't want to sell these parts to hobbyists, is the bottom line. They want to sell them to people who make commercial products and buy millions. So they restrict the data sheets, but what they do call it is complex phase quadrature demodulation and mixing. You could just as well call that multi-phase. And we've heard that term before. You'll find it on the handout in front of you. In fact, they mix 16 phases. I'm not sure I get shot for telling you that, but you didn't hear it here. So very sophisticated stuff going on inside these silicon-based tuners, which we can now do SDRs with. And we'll talk about how good they are and what they're good for next, because I just want to sum up this piece of it by saying, if you look at this on a timeline, the first thing that I said was kind of had in common those early technologies, they're all direct conversion. Remember, when you take a crystal set, you're peeling the audio modulation right off the carrier. So that's direct conversion, direct to baseband. When Armstrong invented the superhet, why did he do that? Well, it wasn't because regens weren't hot enough. I mean, we all know regens are pretty amazing, but it was for improved selectivity, right? So he needed to down convert or up convert to an IF, amplify and filter, and then turn it into baseband audio. So 50 years later, we're back to direct conversion, which is kind of interesting. I mean, the superhet really dominated all during that period, right? If you think about your boat anchors, whether it's Collins S-line or, a K3, they're superhet architectures. K3 happens to have a really nice DSP back end on it, but its performance comes from the fact that it has a good radio out in front with good filters. I'm not saying the superhet's dead, but I think we're moving away from it. So we went from this really exciting period of innovation where things happened every few years, kind of into a period of stagnation. There weren't a lot of receiver innovations for about 50 years. Transistors came along, and then we started combining Jack Kilby and the guys at TI in, I think, 1958, quote, invented the IC. I mean, that was just really making transistors together, putting a bunch of them on a piece of silicon. But transistors were viewed as just a better tube, right? You made transistor radios that used less power and ran on smaller batteries, but didn't do anything a regular radio didn't do. And once we got ICs, they were limited by the technology to being either digital logic or low-speed types of analog. So they weren't really good for radio for a while. And now we're back into this, I think, very fast innovation mode again. A lot of that innovation is being done in other parts of the world. There's very active groups in Europe. There's very active groups in Australia, New Zealand. They're playing with radio too. If you try to build stuff, everybody knows what happened to International Crystal, right? If you try to build things out of coils and capacitors, they're getting hard to find. Try to find a variable capacitor that isn't basically a crystal set tuner, and they're pretty tough to find. So as analog radio parts become obsolete, because analog radios are becoming obsolete. And that's just the way it is. So my challenge is, how do I learn how to make radios out of this newfangled stuff? And believe me, I am not the DSP software guy. I happen to know one who's really good, and I enjoy working with them. And I bring some of the ham, maybe savvy, I don't know. But in 50 years, you pick up a few things in radio about what's good and what you like and what you don't like, and that's really what you're going to hear here is my preferences. But I really do believe that software-defined radio is the future, and silicon is going to play. Silicon-based SDRs are going to be a piece of that. But if you're sitting out there saying, so what? I got a nice radio. I can talk to my friends. I can do what I want to do. I don't need any of this stuff. You're probably right. But let me tell you what you might think about. This is the way I define performance, and it's sure not the way Rob Sherwood defines performance. And I'm not smart enough to sit there and digest a bunch of SDR specs and a bunch of conventional receiver specs. I know the website to go to where I want to do that. But what I really want to know is a couple of things. I want to know, does it work for my kind of operation, for what I want to do? Does it work where I need to do it? And that makes a difference. And then, does it have the level of integration that I like? So those are a whole different way of looking at performance. But, if I'm a guy who really wants to do typical ham stuff, what do I do with this? I mean, I got to have a computer. I don't have a computer all the time. When I got my B&W 5100 or my DX100 going, I don't have a place to plug that in. Well, I do now, actually. That's what I'm going to show you. So, first question, what kind of operating do you do? You like to go out and do field portable, QRP, SOTA, pedestrian mobile? I think this is the ultimate picture of casual operation from the TV show, right? You just like to yak with your buddies. A lot of us do. Or are you a contester? Got some of them in the room. Whole different world there. Whole different set of requirements. Or are you a DXer? Again, kind of a different set of requirements. So understanding what kind of operating you're going to do is the first thing I would think about. Where will you do it? Well, folks are constrained. Some people do live in city apartments and all they can manage is a balcony whip. Others, are fortunate and get out and sub nice place for antennas. Some can really get out and spread like Rod. Build a whole HF station out in the middle of Iowa somewhere where there's, or you can even take it to an extreme Could you beat that for a DX location? And by the way, those guys copied my 2-watt whisper beacon on 80 meters like 40 times last night. So location makes a difference. And why? The reason why is this. And if you haven't seen these charts, it's worth looking at. Everybody talks about, I don't even have one handy, but you know what we've all become accustomed to now is switching power supplies. The noise floor goes up, right? And so our need for a sensitive receiver kind of goes down because we're not going to hear anything but noise anyway. And according to this ITU-R study, about 128 dBm, that line right there, is pretty much what you're going to hear in a typical receiver. It doesn't take a really great receiver to hear 128 minus 128 dBm. It's good, but it's not the best. You got receivers out there, what, minus 140 MDS? Well, you can use that minus 140 if you're working 10 meters or maybe 12 meters and you live in a really quiet dotted line rural neighborhood. But if you're on 75 meters, and you're working down in here, take a look at what the noise floor is like, and you're not going to be able to need. So my only point is, think about what you're going to do. Rob?
That top line, residential, that should be higher today.
So you're saying it's even worse. I'm trying to paint a picture, and it's even worse. So that's the reality. And we can still enjoy radio. I mean, thank goodness. My colleague on the DSP side is in Scotland, where television and internet is distributed by VDSL. And if you want to see a mess, I mean, you used to be able to look, I think it's even gone further now, at 12 megahertz, here's your noise floor, and then it takes a step up because all that garbage that's coming off those lines, and the reason is they bury the fiber, but then they distribute the signal to the homes over overhead copper. And yeah, you can say it's twisted pair and it's not going to radiate. They notch the ham bands, but it's a mess. And our GSB is all over it, and I don't think I can do much about it. I'm going to use an analogy to talk about receivers a little bit, and forgive the analogy because it's always inaccurate. But it's just a way for me, at least, of thinking about two important parameters of a receiver. The first one's the dynamic range, and the second one is the RF bandwidth. And the reason I think those are important is because back in the old days, what did we do? What was a hot receiver? We looked at the front end tube, and then we looked at how many IFs it had, and then we looked at how good its filters were. Well, we still do the same thing. In an SDR, it's ADC resolution, it's the bandpass filtering, and in a hybrid, which are really popular, and most contest grade transceivers have all that analog stuff on the front end and then a good DSP behind it. So using my analogy is kind of what it looks like. You can make that window skinny, and so skinny you really couldn't see it because they can put roofing filters in, am I correct, Rob? 250 hertz? So that's all the little fragment of a spectrum that your front end is showing to the DSP. So the DSP has it made. You're basically filtering out all the interferers. You're just giving it like a really sharp preselector would do in an analog receiver. We just couldn't build them that sharp. The other parameter, of course, is the dynamic range, and this is what Rob and others, have the know-how and equipment and patience, objectivity to test receivers to, and you can go read those numbers. They're very impressive. I mean, when you look at what they're capable of doing in a given bandwidth, it's amazing. So the question is, do you need that? And yeah, we talk about battle conditions. When it really gets battle conditions, I turn the radio off. It's like, I'm not going to fight that. But some do. Some need to work contests and do other things. On the SDR side, and I'm talking about a wideband SDR now, no roofing filters possible. Even one of the better SDRs that's been around for many years is a Perseus. It has a bank of like 10 filters. Well, do the math. You're covering 0 to 30 megahertz, and, each filter is still going to be pretty darn wide. It's nothing like the roofing filters are. Well, what does that mean? It still means you can have a pretty good receiver, but you're not going to get the close-in blocking dynamic range that you can get if you add the tracking filters or the roofing filters. I mean, you can have automatic tracking filters, and what's in this little guy are listed below. There's a low-pass filter that kicks in below 5 megs. There's a 5 to 10 band pass, a 10 to 17 band pass, and a 17 and up high pass. Is that perfect? No, but it's pretty good because we can get 100 dB with 100 kilohertz interferer, and it knocks out most of the junk that you don't care about when you're on a given amateur band. So that's another way of looking at why this kind of window analogy, I guess, makes sense to me. Now, what can we do to optimize? If you want to deal with really strong signals, we can jack the window up. And what we're basically doing is taking this fixed dynamic range that's determined by its design and just making it less sensitive. By adding attenuation, we're going to sacrifice some of those weak signals, but we can't hear them anyway in most cases because the noise of the receiver, the noise level of the receiver is below what we can probably use because of the noise level, the noise floor, and now we can basically have greater immunity to stronger signals. So that's what attenuation can do. You can also fiddle with another button and turn on a preamp or an LNA. That helps you optimize for weak signals by pushing the window down. So now you're at the noise floor. You can hear all those weak signals on 10 meters, but it's at the cost of a little dynamic range on the top end. So again, the more you understand about how this stuff kind of works, and believe me, I'm learning, the easier it is to, I think, have a better understanding for what you're buying, what you're paying for, and how it works when you put it on the air. And finally, what you really want, and what they had for the superhet era, is AGC. And AGC is sort of like magic because it's like this little motor that runs that window up and down automatically for you and maximizes, at least to a certain extent, the dynamic range that you can take advantage of. The chip, the silicon tuner here, has 48 dB that's tunable in 6 dB increments. So it's kind of sitting in there running the gain itself, and you don't have to. And that's pretty useful, as I hope to demonstrate. So it's a little bit about the type operation and location, and I'm going to now talk about the third piece that I referred to, which is the level of integration. Because again, I don't have screw terminals on the back of my PC. I don't have a coax connector on the back of it. How do I make an SDR work in the real ham shack? And what's a real ham shack? This doesn't resemble anybody here, does it? I don't think. I mean, we're all going to sit there. Yeah, it does kind of look like a Harvey. We're all going to sit there and make at least 50 dBm of our RF, right? I mean, that's kind of what we're going to do. I happen to bring a little low power transceiver here. It only makes about 30, I guess, or more than that, 40. But we're going to make high levels of RF in our shacks. We're going to want these pretty sensitive receivers to work with that. So there's a problem. As I talk to people, what they tell me is they really want to use an SDR, not just as a pan adapter connected to their IF output. They'll do that. But they also want to use it as a second receiver. But how many of us have got duplicates of every antenna? So if you're on 75 meters, you probably got a dipole or a vertical or something. And you want to hear those same signals with the same signal strength on your second receiver that you're fooling around with, maybe, seeing if there's anybody up on the net frequency while you're working somebody else. So you really want both receivers connected to the antenna at the same time. You need to have protection then against this high level of RF that is going to exist in the shack. It's high enough to burn things up, believe me. Don't ask how I know. SDRs have latency, so everything you say now is going to be played back to you a tenth or 2/10 of a second later. Pretty annoying if you don't have a way of muting. And again, it's kind of got to be not just protected from your transmitter, and this is a lesson I learned, but if you leave it hooked up to antenna A and you go over and start running a kilowatt on antenna B, guess what? You can come back and find little charcoal colored parts on your front end. So how did we deal with this issue in the past? Well, we all know these guys, right? Good old Dow key. Well, or a TR switch, and there's been some research, some studies done. The problem is, even the electronic TR switch lets too much RF through until that tube clamps off to isolate the receiver. It wasn't a problem if you were talking about an NC303 or something, but it is a problem with an SDR. I came up with this approach, and I put it in QST article back in 2018, mainly because I was tired of running around filing the contacts and trying to persuade Dow keys to work. I don't know, I have terrible luck with those things, on the receive side especially. So I said, I'm just going to make a TR switch. And by the way, I'm going to make it RF actuated. So I like to play kind of to my detriment. I'm the guy who wanted to put a transmitter on that has no audio or something because it blew up. But, if I want to hook up a Globe Scout or Globe Chief or something that's doesn't have a TR relay in it, it just puts a toggle switch that you turn on. This will take care of switching. And I also wanted to be able to use it with the SDRs. But it provides enough protection because it switches the antenna and it grounds the receive terminal. It'll give at least 60, 70 dB probably. I forget, but it doesn't simultaneously allow the receiver to be connected. It's a TR switch, T or R. And I got a lot of questions from people saying, well, this let me do that. And I said, no, it's not meant to do that. One reason was MFJ was trying to do that, and they stumbled, and I kind of stood back and said, better you than me. But they came up with the 1708, which is an RF sensing TR switch. I think they did a pretty good job on this product. Anybody use one of these? Yeah, what do you think? It works? Adequate? It's adequate? They did a pretty good job of protection. It does have a splitter in it. And I looked at that and I said, man, some of those guys at DXers ain't going to like that. Losing 3 dB. Well, I talked to DXer and he says, look what's in the K3. It's got a splitter in it. So I said, well, okay, remember back to the chart, knowing what you're doing and why you're trying to do it. Unless you're really down in the noise, you're not going to miss 3 dB. You probably got more gain than you need. So I've kind of borrowed from that to create what I call a TR protector. And I'll just hand one of these around if you want to look at it. I like to design stuff and I like to amuse myself, and sometimes we offer them as kits and amuse other people. I wanted to just make it kind of like the Versa TR, only one that did have a splitter, had a few more features, and I wanted to make it easier to connect to an SDR. So I'll just explain a few of those things. It does have 3 dB loss in the splitter, so it's not, for the weak signal guy. However, it is, I hope, like MFJ figured out, needs to be fail-safe. So if you pull a plug, it's a wire. Transmitter is always connected to the antenna through normally closed mechanical contacts. There's no circuitry involved. Hopefully that keeps it from damaging anything. It does provide for the simultaneous receiving. They're both protected. The SDR port's a little more protected because it's actually grounded. The other was kind of a freebie, and if you're using this this works with either a hardware key line, like you can get out of the back of your radio, key and amplifier with, and it provides a set of auxiliary contacts. So if you use those contacts to key this box, you can use its contacts to key your amplifier. And it can be RF sensing. It's got delay, and those features can be jumper selected, so it's pretty easy. I added a little bit to the MFJ product. I made it so you could use a separate receiver. So if you want to use this with boat anchors, you can. It works just fine. And you can still attach the SDR. Now that gets to a use case that I have, because when we're down there on 3885 or something, and I'm trying to hear and there's some idiots on 3880. My good old bandwidth of most of my boat anchors isn't sufficient. So I want that SDR DSP. Well, I can have that now, and I'll show you how it's hooked up. Last thing is it's got a connector, it's got a phone jack on it, and that's for my SDR power and muting. So my idea of integration is you should be able to have these boxes around your shack, you walk up, plug in your SDR, and you're ready to go. You got an antenna connection that's protected, and you got a signal that can tell it when to mute, and basically that's just using the RF sensing. So whether you use an RF sensing to control the relays or not, it's still sending a signal up to the computer. Well, again, I don't have screw terminals in the back of my computer, so what do you do with that? Just a couple more words. These are the pieces that I just went through. You can look at it, and it's got real connectors too, which people use. This is how well it works, and I'm not done with this, by the way. This is always a work in process, but I wanted it to be flat through 30 megs, and I wanted good low frequency response, so that's how the splitter performs. You can see the transceiver connection is flat because it's a wire. It's got a little return loss, but not enough to worry about. No more than a Dow key. It does drop off at up to around 6 meters, but the good news is if you got an HF through 6 transceiver, it's plugged into the port that's flat. The only thing this is going to affect is the SDR port. So you might get a little drop, and you can hook it up direct. How much attenuation? It's actually sometimes more than this. It depends on the load. And somebody's going to tell me that transmitter isn't very clean. And I will tell you, it was a Harris commercial radio. But the line on the left is my fundamental, and that's at minus 25. So that's with 100 watts going through it, which starts out life at about 50 dBm. And I'm getting 25 dBm in the front end of the SDR, which says it's 75 dB of attenuation. Now that's enough that it not only protects the SDR, which usually can go up to plus 10, plus 20. I don't want to get anywhere near that, for safety reasons. But it also says it's within the range of the AGC. So it's not even going to be blocked. It's going to be working, and hopefully we can show you that. Just a couple of things. I made it fit into an outlet box, a receptacle box, just because they're cheap and available. And I thought, it's going back behind the radio. It doesn't need to be pretty. Good RF performance out of these little relays. They're surprisingly good. You can actually use them up to VHF, UHF. Fail-safe, I mentioned. The RF sensing delay up to a half second. So it works like Vox. You can just talk, and you can key your carrier on CW or sideband and set the delay so it'll be like semi-break-in. It could be made a kit. It's all through hole. And it was really designed to be part of what I consider a Linux-based SDR receiver, which is what I'm going to demonstrate, and hopefully it's going to work. We'll find out. Basically, I've got this box connected in series with the little ZigU. Test 1, 2, 3, 4. Do we see some meter wiggling there? Oh, very good point. Battery. No. There it is. Test 1, 2, 3, 4. 1, 2, 3, 4. Ooh. What do you call that, Bob? Test 1, 2, 3, 4. All right. 72. Probably should tighten up connectors. 72, 74. We'll find out whether that's there. It's basically, I've got a little, hard to wiggle things around. I decided to make a tablet. Now, this isn't the preferred packaging that everybody would like, but I wanted a portable SDR that had a Linux-based receiver in it and something that I could move around and have all self-contained. So that's what I did here, and I'm going to show you you're not really stuck with that screen. It's a 5-inch HDMI display, and it's got a touch screen, so I can tune it with that. It's got audio amplifier and and basically the SDR, which could fit inside, but to be able to show and tell and left outside. And that's kind of what it looks like if I took the cover off. Like I say, it's a prototype. But actually fit pretty well. It's a standard Hammond box. And I decided to design an interface board to make all the wiring go away so that it handles power distribution and antenna and audio and everything. So you can still build stuff. Now that's about $125 worth of stuff, so it's not very expensive to play this stuff, play with these things. Raspberry Pis are still $35, and from the Model 3 on up, they're capable of doing SDR, but you need the right application. And that's been kind of hard to find because SDR softwares tend to be Windows based, and that's in the process of changing. So I will show you just real quick. Oops, I've already got it open. I thought. There we go. I'm going to use VNC, if you're familiar with VNC, to show you what's on the little screen. And we'll blow that up. Well, try to blow it up. Thank you. So I now have an SDR program. I'm going to open up. I'm going to use my little, do it over here. I can select in this software things like the mode. It can be more. This will eventually have a plugin, and this is not released software, by the way. It's still under development. The good news is it will run on Windows or Linux or even Android and iOS. So we're really after a universal SDR software platform, which I think the world has wanted for a long time. You can configure a bunch of stuff about the display. And you can configure, there's actually more, I think the windows aren't, yeah, there's some audio things, and as I told Bob Heil, there's going to be a mid-range control here, which will help with our voice articulation. We have paid attention. What we got here is an awful lot of noise. Oh, because we somehow got tuned way down into the low 0 hertz. Let's fix that. Yeah. I'll tell you, there's a lot of noise in this room. Whoops. It's a little easier to tune when you have both hands, but let's go to 72. By the way, I can do it by dragging or direct entry, but again, being somewhat handicapped with 74, I think, is where the radio is set, and I'm going to change the mode over to lower sideband, maybe. Get up there. Where'd the audio go? I wonder if my batteries. Uh-oh. Uh-oh. I guess that's what happens from playing too much in the hotel room. All right, so now bunch of hams, we shouldn't have a problem running, coming up with a 12-volt battery. Well, okay. Take my word for it. If we were to talk, you would see a spike in the middle of the thing and you would hear audio. The problem is we don't have an antenna in here, so I really can't do a proper demonstration anyway. But you can, I guess, give a sense for the fact that if you want to build an SDR receiver and do it reasonably inexpensively, learn a few things in the process, and believe me, I've learned a lot. This will give you pretty good performance. In other words, it's going to take, it's going to be better than most of the receivers we started out life with as young hams. With the adapter, the interface, it's integrated into the station. And for my use cases, which are pretty much casual operating, I'm not a contester or DXer, even if I was, I think it's a useful addition to think about adding what is going to be $150 or less, wideband SDR with really good performance, state-of-the-art silicon, and a universal software platform that will run on just about anything you would ever want to run it on. And that's pretty much what I had to say. Is there any questions that I could answer? Yes?
Where's the software-defined transmitters? Where is that?
You know, I mean, I will tell you this. A lot of the guys working on SDR technology are not hams, right? So they're interested in transmitters, but they're not motivated to spend a lot of energy on them. It's going to change. I mean, it will come. And I'm going to, my friend Pete back here is one who I know has one. There's a project called the Hermes Lite. The Hermes was an SDR made by the Tapper Group. It really was commercialized as the Anon. So if you own an Anon 100 or Anon 10, you basically got a Hermes. It was open source, and they did right by Tapper. K7FO is the fellow who really took it to a lower cost point with the Hermes Lite. It's a DDC, DUC, same architecture as the 7300. What's his name? Jim N2 APB, can't think of his call right now. Another SDR experimenter had a nice design for low-pass filters. So he added those. He's got a 5-watt PA. Pete's in the process of getting one up and running. I've got one that's in the process of occupying a drawer. But we'll get up and running. I had the previous version, which used a commercial demo FPGA board, and it works quite well. That transmits and receives. He uses it a lot on WSPR because he can use it without an amplifier.
What about the red tie?
I think I don't know too much about it. I know what it is, and it's a complex RF chipset, and I can't remember who made it. But yeah, I think it works fine from everything I've heard. I bought one of the Plutos, which is similar. You had the Hack RF before that. These are, I think it's on the Lime platform, maybe. Those things are out there. They're not ham radios. In other words, they don't have filters. They don't have power amplifiers. They don't have receive filters, but those things can be added. And Red Pitaya, I think as far as a DSP platform is, and having, can't remember what its tuning range is innately, but it's probably goes down to cover some HF anyway. They could be made into radios, but it takes that RF stuff on the front end, which you now need to do with bandpass filters and low-pass filters. It still takes a power amplifier. One other technology I would throw out to watch is EER, envelope elimination and restoration, which is the new way of doing power amplification. So instead of linear amplifiers, you basically take the phase, which we know all about, the quadrature phase signal, and you take the amplitude signal. If you know amplitude and phase, you can make any waveform you want. And that's what they do, and they do it in high-level amplifier stages. So your PA is something you can hold in the palm of your hand, and it'll still run 500 watts. So watch for them. It's all making radios, right? Any other questions? Or if not, feel free to ask me later. Yes?
About the software?
Yep.
That was unreleased, but when will we expect that?
It's really imminent. What he's building into it is a plug-in architecture right now. Because, the first job is to make it work. And then the second job is to make it work better. And, if somebody wants to do FT8 or they want to do a digital mode, you need a way to hook that in or build it in. And so that will come through the plug-in architecture. The first reason that this tab doesn't work, this one works. The one that he took off doesn't work. The first tab was, there used to be a recording tab on there. And, it's nice to be able to hit the button and record a guy, both audio. It's a great tool for the workbench if you're working on something to record the IQ. Because then you can go up and sit down and get a cup of coffee and sit in front of your computer with nice speakers and not only hear what you sound like, you can hear what you sound like on the upper sideband or lower. You can look at the spectrum as many times as you want. That's going to be the first plug-in. So we'll get there, but I'd say a couple months. Unfortunately, the guys who are doing this stuff have jobs. It's like if you could just be smart enough to do this and be the age some of us are where you're retired, then you'd have all kinds of time. Another question?
So that's going to be open source then?
Yes, it's going to be open source. How about that? Yeah. And, the reason is, again, you want to be everything to everybody. You got to be really smart, because otherwise they're going to beat you to death with requests for features. And I didn't get this open source stuff myself for a long time. You're doing all this work and you're going to give it away? It's nuts. But it's also the way to make a thing bigger than one person can make it and not have to do all the work yourself. So I've used more than my allotted time. I'm done. Thank you.